booster, in many ways, is really a scaled-up version of the Falcon 9 booster. You'll see a lot of similarities, such as the grid fins, obviously clustering a lot of engines at the base, and the big difference really being that the primary structure is an advanced form of carbon fiber as opposed to aluminum lithium, and that we use autogenous pressurization and we get rid of the helium and the nitrogen. So this uses 42 Raptor engines. There's a lot of engines, but we use 9 on a Falcon 9, and with Falcon Heavy, which should launch early next year, there's 27 engines on the base. So we've got pretty good experience with having a large number of engines. It also gives us redundancy, so that if some of the engines fail, you can still continue the mission and be fine. But the main job of the booster is to accelerate the spaceship to around 8,500 kilometers an hour. For those that are less familiar with orbital dynamics, really it's all about velocity and not about height. So really that's the job of the booster. The booster is like the javelin thrower. Sort of, it's got to toss that javelin, which is the spaceship. In the case of other planets, though, which have a gravity well which is not as deep, so Mars, the moons of Jupiter, conceivably one day maybe even Venus. Venus will be a little trickier, but for most of the solar system, you only need the spaceship. So you don't need the booster if you have a lower gravity well. So no booster is needed on the Moon or Mars or any of the moons of Jupiter or Pluto. You just need the spaceship. The booster is just there for heavy gravity wells. And then we've also been able to optimize the propellant needed for boost back and landing to get it down to about 7% of the liftoff propellant load. We think with some optimization, maybe we can get it down to about 6%. And we've also are now getting quite comfortable with the accuracy of the landing. If you've been watching the Falcon 9 landings, you'll see that they're getting increasingly closer to the bullseye. And we think, particularly with the addition of some thrusters, some maneuvering thrusters, we can actually put the booster right back on the launch stand. And then those fins at the base are essentially centering features to take out any minor position mismatch at the launch site. So it looks like at the base. So we think we only need to gimbal or steer the center cluster of engines. So there's 7 engines in the center cluster. Those would be the ones that move for steering the rocket, and the other ones would be fixed in position, which gives us the best concentration of we can max out the number of engines because we don't have to leave any room for gimbaling or moving the engines. And like I said, this is all designed so that you could actually lose multiple engines even at liftoff or anywhere in flight and continue the mission safely.